Hi, it's Dennis here. I thought we might have a look at a protection module which is commonly used on semi-hermetics. The semi-hermetic below here is a bitzer, and semi-hermetics have got a little bit more protection in them than most other systems. Typically, as we start getting larger in size and capacity of units, we tend to see a lot more afforded protection to these units. Semi-hermetics are sort of one of my personal favourites, mainly because when they're installed correctly and done properly, they last for a long time. And the protection in them is superb, given the fact that there is a lot of sensors put into the motor stator to check for abnormal heat. When we look at the overview of the electrical box, in this case you're seeing a three-phase motor designed for a star delta bus. We can see the protection module sitting in here inconspicuously, and unfortunately at times I've been to sites where these things have been ignored. Now I know that doesn't happen. Majority of times we're going to see them installed, but occasionally people just don't know what they're for. This particular unit is made by Lodin. It's an SEB1, it stands for a Signal Evaluation Basic Model 1. This particular company is owned by Bitzer. The protection module itself is fairly straightforward. It comprises of only a few inputs, and basically what we have is that we have a line and neutral input coming in from the top. We have a bus link here which is designed to be factory linked out, but if preferred it can be removed and put into a lockout chain for an external lockout input. If you wish to shut this compressor down for some other particular reason, like for instance you may interface it with an oil failure switch if it had an oil failure switch on it, or perhaps you'd like a building lockout input or something like that to drop all the equipment out, but typically it's bridged out. And then we have up here, we have the common input compressor run output for your compressor running contactor, and a fault output. And realistically that's it. The only thing that's coming out of the module here is the orange wires which are going onto a thermistor input. Now this could have from 1 to 9 sensors inside the unit. These are PTC thermistors and they're all in a series loop, and the idea being that any one of them could increase its temperature and resistance because of a fault anywhere within the motor itself, and then it would bring the total resistance up to trip the unit. So when we have a look at this, it's always important to know exactly what sort of resistance would be normal. One of the things you don't do when you come across to a semi-hermetic unit, or one that has a protection module in it with this arrangement, is if it has tripped out on a fault, say it's overheated, the last thing you want to do is try and bypass this controller to see if it runs. Obviously there's a problem. And importantly, it's really good to know what sort of information we need to know to establish whether there has been a problem or whether the module itself may have had some problem through misadventure, in case there was something that's caused a problem with the module itself. You've only got 2 little connections to check there, and these can be easily done with resistance meters. But what you need to get though is you need to get the information from the manufacturer as to what you're expecting to see. And over here I've got a nice blown out section which has come off their site, and information which talks about the sensitivities of the thermistors themselves. In this particular case, the resistance that would trigger this is about 4.5 k ohms plus or minus 5%, with a reset range of about 2.7 k ohms. And a maximum total resistance usually less than 1.8 kilo ohms when it's normal. And obviously that can be lower than that. And a whole load of other technical data. You also have information on the wiring inputs, which I've expanded here so we can see it a little easy. You can see here that we've got a line coming in, feeding up to our common supply. We've got a negative. We have a normally open, which switches over when everything is normal, and a normally closed, which would go out to the fault circuit. In its current position, the normally closed is feeding the fault line on this particular model, and in its rest position it would be connected between those two, and some people assume that those are the ones feeding the compressor by default, which they're not. So it's very important to have a look at it. If you have a look up at other information, you can clearly see where it's meant to go, and also if we have a look over at the compressor box, we can see that the lid gives us a bit of information as well as to how it's recommended to be wired up. Now, if you know this information, you can simply get yourself a meter and set the meter to resistance mode and do a basic resistance test across it. So here we can simply put our probes across the meter itself, across these two here, and we will get a reading across those two. And you can see here that it's about 173 ohms, which obviously isn't a problem. But on site, what you would be looking for is whether you would have a problem there where you've got a situation where the thing has overheated and you're expecting to see that trigger resistance. So what I've done for you here is I've actually got one of these constructed into a test box. And this test box here contains the same protection module, and I've got up top there a fault and a run light, which is representing compressor run and a fault. Down the bottom here we have an on-off switch, and then we have a pot here, a variable pot, which changes the resistance anywhere between 0 and 10k ohms, which allows us to test this particular device. If I turn it on, I've got the controller set on low resistance at this particular stage. You'll see that our little green run light is on. Everything's happy at this stage. As I slowly increase the resistance, once the module gets to the point at which we get the trigger resistance, it'll actually swing across to a fault, which it's done at the moment, and the unit will drop out, and it's just that simple. It won't matter whether you turn it off and on again. If the unit is hot, if it's putting this high resistance back in because it's heated up, it's still going to be on fault. One of the things which I do like about this particular unit is that even if we turn this down to a lower setting, you just can't reset it. You just can't reset the unit completely on and off unless, of course, you've given it sufficient off time. So here, I've got it back on again, and I'm going to cause another fault again by turning this dial up to the resistance range to trigger it. And then what I'm going to do is I'm going to wind this back down to a minimal resistance, and it requires a reset, but the reset just can't be done by turning this off and on quickly. You have to give it sufficient reset time, and in this case it's approximately 5 seconds. So if I turn that off and we wait that nominated time, we'll see that when we turn it on again, away she goes. So it's a very simple device and very simple arrangement for protection, but it's doing a very important job. Now obviously we can't get inside the semi-hermetic to try and look at all these things. These are inherently embedded in there. So once they're in for life. The last thing we want to do is risk motor failure by trying to bypass these devices just to test a motor because it's tripped out. So importantly, what you need to know is the correct range of resistance that was going to generate a fault into this module, and test it accordingly as simply as I've done here. And that should make it easy for you on site to determine if there is a problem. Now obviously if you have had a fault with this and it has heated up, it'd be a good idea to let it allow sufficient time to cool down. There's not a great deal that you can do about that. And then look into the reasons why you've had some significant overheat here. Again, I don't recommend whatsoever that you try and bypass this unit or anything like this to try and see if the motor gets going, because it could be at that moment that you do the most significant damage. Okay, I hope you've enjoyed this, and I'll catch you all next time.